results, my instructional video I'm about to presentate is about Ohm's law applied to series and parallel circuits. Ohm's law. This is the Ohm's law triangle. At the very top here you have voltage, current, resistance. Voltage is measured in volts, V. Current is measured in amps, I. And resistance is measured in ohms, R. If you're in a circuit and you need to find voltage, you take the current times the resistance. To find the current, you take the voltage over the resistance. And to find resistance, you take voltage over current. You take voltage. This is a circuit without the voltage. This symbol here stands for your battery supply. This would be your current, 10 milliamps. And this symbol is your resistor. And that will be measured by resistance. To find the voltage, you take your current times your resistance. You take your 10 milliamps, but you have to take your milliamps and convert it into amps. So you move 3 places to the left, which will give you 0.01 milliamps. Then you times it by your 1K resistor, which is 1,000 ohms. Times that, and you get 10 volts. That's how you find voltage. That's how you find voltage. Okay. Again, this is your battery and your resistor. For your battery, you have 10 volts. For your resistor, you have a 1K, and you do not have the current this time. To find current, you take voltage over resistance. This time, your voltage is 10, and your resistance is 1K, 1,000 ohms. You take 10 and divide by 1,000, which will give you 0.01 amps. To take and transfer that to milliamps, you move the decimal place 1, 2, 3 places to the right, which gives you 10 milliamps. That's how you find current in a parallel circuit. Current does not stay the same. Voltage stays the same. And another difference between a series and a parallel is parallel has 2 paths you can travel. To find the resistance total in a parallel, you have to take product over sum. For example, 1K resistor and a 1K resistor. 1,000 times 1,000 over 1,000 plus 1,000. This will leave us with 0.5 mega ohms. Since the voltage stays the same in a parallel circuit, 10 volts will travel through both points in the circuit and stay the same. Current, on the other hand, will change. You'll have to take 10 volts over the 1K resistor. That will leave you with 10 milliamps. But since they're both 1K resistors, they will both be 10 milliamps for this circuit. In this circuit, you have to find the current. The current is found by taking your volts over your resistance. If I go to my multimeter here, I click on the amps, and I click anywhere in the circuit, I'll find out that my amperes are 10 milliamps. And the next circuit is a series circuit. To find the total resistance in the circuit, you add the 2 resistors together. 2,000 ohms would be my total. To find my amperes, click anywhere in the circuit. It is 5 milliamps here, and if I click on the resistor, it's 5 milliamps here, and it should be the same on the other resistor due to the fact that they are the same type resistor, and that current stays the same in the series. My next circuit is a parallel circuit. In my parallel circuit, I have to take product over sum. When I take product over sum, I will receive an answer of 500 ohms. These 500 ohms will have a different current, but since in this circuit they're the 2 same resistors, they will have a total of the same current. And my current in this circuit at resistor 1 is 5, and here is 5. So that will give me a total of 10 milliamps.
I run power to it with the brown.
have a thread board with a project built onto it, which will give you a visual of what a circuit looks like up close. Here we have a 9-volt battery, which is connected to our thread board. This is our thread board. And attached to this thread board, we have LEDs, capacitors, diodes. We also have IC chips and a clock. The IC chips are kind of like little gate systems which allow current to pass through different areas. Our LEDs are light emitting diodes, and they blink when you pass current through them. And what makes them blink is we have capacitors here that are attached to them, and the capacitors give out short bolts of current, and that will make it blink. Here on our clock, we have it counting random numbers, and then when we hit this push button switch, it starts back at 0. And it keeps on counting down. Here is what it looks like in our circuit form.